This video covers the primary financial functions in Microsoft Excel. Everything in this video also applies to Google Sheets. All right, so the way this works is we've got 5 functions, and they're called PV, NPER, Rate, PMT, and FV, standing for present value, number of periods, rate, payment, and future value. And these are the 5 variables, but they also refer to the 5 functions. And the way it works is if you have 4 of them and you need the 5th one, you put it in the function named after the 5th one that you need, and it'll give you the 5th one. So we're going to do a couple of examples, all using sort of simple financial scenarios. In our first example, we're going to talk about our friend Billy, who's saving up for a car. So how much does he have right now? He has 0, so that's the present value. And he is going to put it in his bank account, which pays him, let's say, 6% interest. Now, of course, 6% annual, we're going to deal with months because that's the way banks work and that's the way finance works in general. So we're actually going to put our annual rate right here, and that's going to be 6%, and therefore our rate will be that divided by 12 because there's 12 months in a year, of course. So he's getting that, and the next thing we need is his payment, and his plan is to put $150 into the bank account every month. So that's going to be a $150 payment. And the future value, he needs $10,000 to buy his car. It's a really nice, badly damaged Kia, apparently. So we're going to do $10,000 there. Now, here's the thing. The future value has to be the opposite sign of the payment in this case, because the payment is what he's putting into the bank, and the future value, that $10,000 he's looking to get, is what he can take out of the bank. And that's why it's the opposite sign. So we're actually going to put in negative $10,000. And the question is, how long will it take for him to save up the $10,000 he needs? And that's going to be number of periods. How many periods will he need? NPER. So right here, we're going to put the NPER function, NPER, and it wants, in this order, it first wants the rate, so give it the rate, then it wants the payment, then it wants the present value, which is 0 because he doesn't have any money there yet, and then it wants the future value. And we learn that it will take him 57.68 periods, or 57.68 months, to save up $10,000 if he's putting $150 in the bank and getting 6% annual interest. And there we go. Now, our friend, what was his name? Billy? No, let's call him Kevin. Kevin now has the same goal, except he wants to get it in, let's say, 24 months. He needs to buy this car in 2 years. So we're going to put, for number of periods, 24, and he wants to know how much of the payment will he have to put in each month to make that $10,000 in the 24 months. And for that, we'll use the PMT function. So right here in PMT, we'll do equals PMT, and then it wants first the rate, then it wants the number of periods, which would be 24, then it wants the present value, 0, again, because he doesn't have anything, and then it wants the future value, negative 10,000. Did I do that right? Yep. And now we find out that he needs to actually put into the bank $393.21 each month if he wants to have the $10,000 in 24 months. Let's shift gears a little bit and look at a mortgage. And the way a mortgage works, it starts out, the present value is the balance, and then the future value is when you pay it off would be 0. So we want to know, we're getting, by coincidence, we're still getting a 6% rate on our mortgage, and we want to know how much house can we afford. And a mortgage is generally 30 years or 360 periods, months. So we'll put 360 for the NPER. And the present value we want to find out. The future value is going to be 0 because we want it to be paid off at the end. And the payment, we decided that we can afford $2,000 a month, let's say, in a mortgage payment. So we'll put $2,000 right there. And oops, we got to spread that out a little bit. Good. $2,000. And the rate is still 0.005. Let's change that to percent just to be a little bit clearer, because that's the monthly rate. And we want to know how much house can we afford. So with the payment being $2,000, we want to know what's the appropriate present value of the mortgage. So we'll do equals PV, and first it wants the rate again. Then it wants NPER, which is at 360. Then it wants the payment amount, and then it wants the future value, which again is 0 because it'll be paid off at the end. And we find out, again, it's the opposite sign for the same reason that I explained earlier, but we find out that we can afford a house that is, ignore the down payment thing, whatever, but we can afford a house, we can afford a mortgage that's worth $333,500. And that's the present value function, PV. Now let's change things a little bit. We want to, let's say, buy a house for $500,000. So I'm going to do negative $500,000. And it's still the same 360-month mortgage, but we want to pay $2,500 a month. And, $2,500 a month. And we want to know what rate do we need in order to achieve that. So we'll go into rate, and we'll do equals rate function. And the number of periods is 360. The payment is right there. The present value is going to be the negative 500,000. The future value, again, is 0. And let's see what happens. We find out that we need 0.4%, which, of course, is the monthly. So if we multiply that by 12, we find out that we need a 4.39% mortgage in order to buy that $500,000 house while paying a monthly payment of $2,500. Perfect. And there you go. That's just about our financial functions. And there is one thing I should mention. Each of the functions has a fifth optional variable, which, if you notice, is called type. And that is, when in a month do you pay it? 0, or the default, is the end of the month. 1 is going to be the beginning of the month. So, for instance, when you're paying off a mortgage, you pay at the beginning of the month. So it actually should have been a 1 there for the mortgage. It'll change the numbers just a little bit. On the other hand, if it's a bank account paying you interest, the interest comes at the end of each month. So it would be a 1 in that case. And that's all there is to it. So I think you're good to go.